Hey guys, in this tutorial, I'm gonna draw this diagram. It's quite simple, I guess. But you have to select the polar coordinate. That will be much easier, I guess. So let's hide all these. You can keep that because it's just the speed of the render time. So, oh, something is mistake. Oh, sorry, I have entered this involvement as well. So yeah, so let's create a like a center environment. Begin center, and then inside that we can nest text picture. Okay, so firstly we have access. I'm gonna use TZ plot, and that will be easier to draw here. So firstly let's define few coordinates. So firstly we will define origin, which is 0 comma 0, and we call it O. Okay, and yeah, we can put node here, so node as O, and let's put here 225. 225 is kind of a location. It represents the angular location. Here we could have put it like 180 as well, no problem. So let's run it first. Let me increase the editor size, and now we should make access. So digit access, and we have to go like 0 comma 0 because we are from drawing only positive sides. Okay, so let's say 5 comma 4. First we call it x, and then we call it by. Okay, so as you can see, this is the coordinate, and now we have to define all these coordinate systems. So firstly let's call it uh, it's my this is minus q, or this is minus q. Let me read the question. An electric dipole is formed by two charge plus q minus q in the xy plane at 0 comma 2. Where is 0 comma 2? Oh, sorry, axis is like this. And respectively electric potential at point P due to dipole is, we know, the charge plus q, and then moved to plus q will move to like minus 1 comma 2, and then minus q will move to 1 comma minus 2 here. Okay, and what is the value of electric potential at, okay, so let's define few coordinates. So firstly let's call it plus q. So tz core, we are using a star version, that means it will make uh, a small circle as well, so call it 1 unit, and then we can call it q plus, I don't know, chalo qp, that means q plus. Okay, we name this coordinate and we're gonna put node as well. So node here is plus q, and position of node is like at 150 135 degree. So let's call it 135. So you will see a charge here. Okay, and then we can again copy this part and paste for q minus. Q minus is x is still 0, but this time minus by axis, and then after q is 180, minus q is at 180, or let's no, I think keep it at 225. So yeah, this is sorry, minus q, and let's draw this coordinate actually. So again we're gonna call it tz core, and this time we're gonna call 1 comma minus 2, 1 comma minus 2, and the location of this coordinate is like q minus dash, because it is shifted like new coordinate. Okay, and we're gonna put some node here, which is 1 comma minus 2, and then will be in millimeter. Okay, and its location is 0, so we can call it 0. So yeah, it's perfectly okay, and again we can copy this coordinate, and then after we just have to replace the coordinate which is this one minus 1 comma 2, so this is minus 1 and this is plus 2, and then this is positive charge shifted coordinate, so like this, and this will be minus 1 plus 2, and at this time we want to add 180 degree, so this in this direction, so as you see, and now we have to make a final coordinate which is p. So again we're gonna just call it, let's paste, and we're gonna call it at 45 degree, and we have 2 millimeter 100. Okay, so this is 100 and x is also 100, and let's call p. Okay, and let's call this coordinate as p. So this will be at like 4 comma 4, both x and y coordinates are equal, so I guess it's okay. Let's decrease a bit, let's call it 3.5. 4.5 is quite, sorry, 4 is quite large, so we reduce to 3.5, that will be nearby. Yeah, and now we have to just join the lines. One more thing we have to do is like we have to put this coordinate 0 comma 2 and 0 comma minus 2, so where it is plus q. Yeah, so let's call it 0 comma 2 and then millimeter, and minus 0 comma minus 2 and again millimeter. I guess we have to use 270, I guess. So yeah, 270, and we have to use it at 90, that will be better. So yeah, as you can see, it's okay. Now we have to just join the line. So TZ line, we can actually use TZ lines. Okay, so firstly we have to join on every line should be dashed, so dashed, and then first line we are going to join is O to P, so we call it O, then we call it P, and then another line we're going to join is O to this point plus Q, so Q plus, and again O2 Q minus, so Q minus. Let me just finish this, then after we can extend. So as you can see, every line is perfectly, and then further we have to join these lines too. So again it's O2 Q plus dash, and then again O2 Q minus dash part, or you can say complement part. So as you can see, it all drawn and dashed. I think spelling is okay. So I don't know how it is solid. Just decrease the size. It will. I don't know why it's happening. So I guess in the actual PDF we will get dashed looking version, because sometimes yeah it happens. Let me just check it. So this is the PDF. No, it is not a dashed part. Why? Every line is dashed. Let me use the TikZ version. I guess that will do the job. Draw dashed, and for text we just have to add a double dash in between the lines. And see what happens. So yeah, now it's okay. We have to use like TikZ actual command to draw dashed continuously. So I guess yeah, this diagram is done. I think it's quite good. Every position is perfectly represented. And if you are wondering why this is given in between line, because it represents, this line is quite large. Their dimension is not accurately represented with respect to this diagram. For this also, this line is extended infinitely. Again, this line is extended infinitely. beyond this paper, you can call it. So I'm not gonna do that, just let it be. So I hope this diagram is done here. And earlier in the video I said we have to use polar coordinate but not, because all these coordinates are given. I didn't think through, so I thought let's define according to angles, but here every coordinate is given, so we just have to put the coordinate properly. Okay, thank you, see you in the next one.